Hello. In this video, we will demonstrate to you how we have taught TIAGo to solve a Rubik's Cube. Here you can see TIAGo holding the Rubik's Cube in its gripper. To simulate the cube, we used April tags, which are glued to the center square of each face. In this scene, TIAGo begins calibrating the Rubik's Cube. To do this, a specific calibration flow is followed, where the April tags are brought into relation with each other. TIAGo examines each face of the Rubik's Cube and memorizes the orientation of each April tag. We can also view the calibration process from TIAGo's perspective, with the simulation shown on the left side of the screen and the camera view on the right. Notice the moment at the end when the calibration is complete, as it becomes clear that the Rubik's Cube is now properly simulated. Once the calibration of the Rubik's Cube is complete and the simulation is accurate, TIAGo continues by detecting the colors of the squares on all 6 faces. TIAGo's perspective is now much more interesting, as we can see the Rubik's Cube is fully simulated. As soon as the colors are detected, they are also visible in the simulation. To emphasize what it means for the cube to be fully simulated, it is demonstrated manually. Following the successful calibration and color detection, the initial state of the Rubik's Cube is passed to a solving algorithm. This algorithm generates the moves that TIAGo needs to perform to solve the cube. The 6 moves that TIAGo can use to solve the Rubik's Cube are predefined and can be seamlessly combined, although some faces are easier to rotate than others, resulting in varying complexity for different movement sequences. Finally, after all the steps we've covered, TIAGo combines the moves from the solver algorithm to solve the cube. Here is the result. Now that the demonstration is over, a few final comments on potential improvements. One issue, as shown in the current scene, is the increasing noise in data as the Rubik's Cube moves farther away from TIAGo. Another challenge occurs when the Rubik's Cube is moved at a fast pace, causing the tracking of the center points of the squares to produce inaccurate data. In conclusion, both of these problems can be addressed by accelerating the April tag detection algorithm through hardware implementation using FPGAs. The increase in performance would enable a higher frame rate and resolution, allowing the camera to dynamically track the cube. This would reduce the complexity of the moves, correct movement errors, and significantly speed up cube tracking. Thank you for your interest in our project and for watching the video. Goodbye.